now we start leading into our QA sections. And I would like to let you know that you will be able to submit your questions directly to the facilitator via Slido. I think is, simply open your web browser and go to slido.com and enter with the event code that is that one. However, if you prefer to ask your question in front of the audience, please make your way to the microphone positioned at the center of the room. I think there is one there and one at the back, but I strongly recommend this. So we start with the first with the first panel, and that is dedicated to research and development. In particular, this is around the SmartSat Cooperative Research Center, leapfrogging to R&D to help building Australian space industry. I would like to welcome, as a facilitator, my good friend, Dr. Christyl Johnson, the Goddard Deputy Director for Technology and Research Investment from NASA, and as a panelist, Professor Andy Koronios, Chief Executive Officer of SmartSat Cooperative Research Center, Dr. Peter Woodgate, Chair of SmartSat CRC Board, Greg Smith, Chief Executive Officer of EOS Space System, Dr. Kimberley Clayfield, leader of the CSIRO Space Technology Future Science Platform, and Bruno Vicentini, Chief Operating Officer of E-Geos Telespazio. Please welcome, this member of the panel. Please.
All right, good morning. Good morning. All right, yeah, you don't have the pleasure of just sitting there and not engaging. We definitely want you to be engaged in this conversation. This is kind of the first discussion. The R&D section is going to be something that's going to be very important to the future of the space industry here. And so as we think about it, whenever an organization, I'm going to be actually moderating this panel, so I'm actually just going to do a quick introduction here for just a couple of minutes. Then we're going to give you an opportunity to hear from each of our panel members for 3 to 5 minutes. And then we're going to have some specific questions. I will have some questions for them, and then we're going to open up the questions to you. So be thinking about your questions as they're going through their information so that you can really challenge some of their thinking. So whenever an organization really takes on a challenging mission, when you're trying to do something that's impossible, you have these impossible goals, you always are going to have challenges. You're going to come up with these difficult challenges, and it's going to be very difficult for you to be able to achieve them. The way that you achieve the results and you find solutions to these challenges is for you to innovate. And the best way for you to innovate is to bring outside of the box thinking to the table. It's really a matter of finding those trusted partners in people that are in your field and people who are not in your field that can bring very, very diverse thinking to your solution set. And so that is why it's really important for you to find those trusted sources that you can partner with, and not trying to do things on your own. And that's why many of our nations over the past have always placed great value in teaming with each other and leveraging our resources to be able to come up with some of the solutions to these problems. So when you're thinking about innovation, research and development is a critical part of that. Investments in research and development is a critical piece for economic growth as well. And because each of us, we have a lot of things that we'd like to invest in, but we have very limited resources to invest. That means it's going to take some strategic investments in order to be able to make the biggest impact that we can possibly make as a nation. So one of the great things about innovation also is you can find innovation everywhere, all the way from the person in their garage who is piqued, their interest is piqued, or they're curious about a specific thing, and they're trying to figure it out on their own, Also, these startup companies. You can find some great innovation working with some of these startup companies. And in the university labs, you can come up with some great solutions to some really, really difficult problems, all the way up to the larger organizations that have these skunk work groups that bring great minds together to come up with some of these challenges. So if you really want to go beyond incremental improvements and providing leapfrog space technologies, it requires the ultimate in innovative thinking and strategic partnering. And so with that, I'm going to have the first person come up, or you can stay in your seat there, Peter, and just talk a little bit about what it is that you're going to be bringing to this ecosystem.
Thank you very much, Christyl, and that's a wonderfully inspiring way for us to start, thinking about things out of the box. Can I just say on a personal note, having worked closely with you over the course of this week, and on behalf of many of our colleagues who've had the same privilege as well with you and your team, just what a wonderfully embracing relationship you're developing between the US and Australia. We couldn't be more grateful to you for that, so thank you very much.
Absolutely. I feel like an honorary Australian.
You're certainly that already. Pete Nicholoff has already declared it. So
yeah, there you go.
It must be so. What I'd like to do is to pick up that challenge of an innovative idea, and it's this one. Bringing the space industry and the spatial industry in Australia much closer together for the purpose of accelerating those key goals that we've heard the Prime Minister and our Minister and the Premier and Megan speaking about. That is the 20,000 jobs and the $12 billion uplift in GDP and a multi-billion-dollar pipeline of investment funding by 2030. And the idea would be to accelerate the rate at which we get to those targets and hopefully exceed them by bringing these two industries far more closer together. So why is that of value? First of all, on the space side, we all know the three key classes of space assets that we're using in the downward-looking sense: position, navigation, timing, Earth observation, and communications. So the first two provide us with a stream of information, relatively raw information, but highly valuable. The third is the pipe that actually moves that key data around. We fill that pipe, though, with a whole lot of value-added information, and this is where you get your premium return for the investment in those space assets. And the more precise, the more customised, and the more timely that information flow is using those space assets, the more value and the greater impact that is returned to end users. So the value proposition prima facie is that by having those two industries, their peak bodies and all their key players, operating in a coordinated strategic sense, a roadmap, as it were, looking 10 years out, helps deliver that premium value-added return. Now, the proposal has got to the stage where we've discussed it with many of the key players in both industries, and there is very strong support for it to go ahead. It would have three primary components. The first would be a white paper, which identifies the very important things that we have to do, and also the roadblocks or challenges that we have to overcome, so the problems that we have to overcome. Second one would be an ecosystem map, so that we all have a much more elevated understanding of the roles of all of the key organisations: public, private, publicly funded research, defence and government. And the third would be a risk analysis, a full supply chain risk analysis from end to end, identifying those threats that are existential or that are coming, so that we can much better position all of the players and the nation to be more resilient to those threats and to move beyond them. So that's the proposition.
Perfect, thank you. And Craig.
Thank you. So I'm Craig Smith. I'm the CEO of EOS Space Systems from Electro-Optic Systems. Electro-Optic Systems is, I guess I'm here representing kind of the industry side of where we're going with the SmartSat CRC. EOS is the largest Australian defence and science exporter, and so we're taking technologies to create jobs and also export markets. We've been involved in the forerunner or the previous version of the CRC, or this CRC for the, we were the lead in the CRC for space and environment management. We teamed with some universities, Australian National University, RMIT University, Lockheed Martin Australia, Optus Satellite Systems, and the National Information Telecommunications Division in Japan. So we have a sort of a background in those collaborative industry, government and university and research organisations, development of technologies. It's been a very fruitful and close collaboration. We're very close to some excellent results from coming out of that system, which we would like to publish probably later in the year. So it is, but it reflects, I guess, our view that where those collaborations are really important to us in generating both technology and jobs and export markets.
That's great. Okay, thank you. I'm going to go a little bit out of order. Andy, could you give us a couple opening remarks?
I think you can hear me. Yes, you can. Just to give you a little bit of an idea, particularly for the people that are not aware of what the SmartSat CRC is, it is the CRC stands for a collaborative or collaborative research center. The aim, or our aim, was to bring the researchers within Australia and indeed overseas to work closely together with industry, to bring them to build collaborations between researcher and researcher, but also very importantly between researchers and industry. And we have three key objectives. The first one is R&D, of course, to identify the right technologies for us to research and to bring Australia to a position where they are ahead of the curve in a number of areas, in a small number of areas where we can actually then create some commercial value. And in fact, the CRC program is all about impact, about research that leads to translation, utilization, and commercialization so that we can create commercial value for our partners and for Australia at large. It also has another objective, and that is an education, a workforce development, a capability development task. And that is through our PhD program. We intend to have more than 70 PhD graduations during the life of the CRC, which is 7 years, but also working together with our university partners, with our TAFE colleagues and private providers to build the skills in this very nascent but very fast-growing industry. And finally, of course, it is, of course, our mission, particularly in this CRC, to help build our industry. And we will do that by having the startup ecosystem coalesce together with us for us to support them and to provide them with guidance, with infrastructure, and the backing of some of our global industry partners so that they can survive, they can thrive, they can grow, and hopefully also become global companies. Thank you.
Great, thank you. And Bruno.
Thank you so much. Good morning to everybody. First of all, it is a great pleasure to be here, a great pleasure to be aside to Andy. I really want to pick up the point on innovation and research and development that you made, with a statement made by the Minister of Industry, Science and Technology yesterday. She said, she addressed the economic sustainability of the space industry, and she addressed also the point of delivering values to the communities, delivering values to the citizen. I think that the Earth observation arena is really an example of economic sustainability and also of a dramatic added value that we can provide to the communities and to the system and to the citizens. Let me make a couple of examples of our heritage in Italy, and as a matter of fact, not only in Italy, because we are operating all over the world the Cosmos Climate System, so our market is the world. I recall that 10 years ago, we allocated some funds for research and development in order to develop service for providing emergency response services upon disasters, which could be anthropic or natural. 10 years after, those services are extremely profitable. We are the main contractor for the European Union to provide those services all over the world. And the pattern is changing so fastly that nowadays we have a number of private customers which are accessing the very same services, like insurers or reinsurers that wants to have an immediate understanding of the impacts of events on the field. One more example is the persistent scatter interferometry. Thanks to a stack of data on a given area, we can provide extremely accurate measurements. And when I say accurate, I'm talking about millimeters per year for ground motion or deformation of critical infrastructure. The power of this technique is enormous because when I process a Cosmos Climate image is a 40 by 40 kilometers, so we can generate a risk map over 1,600 kilometers, and where we understand that there is a risk, we can place a GNSS receiver or in situ sensor to have even a better understanding of the ongoing phenomena and to build what we call a digital twin of the infrastructure. You can easily understand what is the benefit for citizens because we can invest money before a bad event is going to happen, which is definitely better than spending money to fix problems.
Okay, thank you. All right, and so now Kimberley actually has some slides she wants to share with you all.
Well, good morning, everyone. I'm very pleased to be here to present on behalf of Sarah Pearce today. Now, CSIRO is, of course, Australia's national science agency. We have a very broad range of R&D interests. My program, the Space Technology Future Science Platform, is actively looking for those leapfrog R&D opportunities that we can grow into commercial opportunities for our industry. You'll probably also be aware that one of our very well-established areas of capability in CSIRO is Earth observation. One of the key areas that we are partnering with the SmartSat CRC on is in water quality monitoring. So I just wanted to talk to you about that for a few minutes. So management of water resources is a critical issue for Australian landscapes, agriculture and communities. From recent fish kills in our rivers to sediment plumes affecting the health of our coral reefs, water quality has become a critical social and political issue in Australia. The quantity of the available water resources in Australia is monitored both through federal and state programs, but when it comes to the quality of our freshwater resources and our coastal waters, Australia actually has no single common and comprehensive monitoring system across all jurisdictions. Internationally, in 2018, the Group on Earth Observations established the AquaWatch initiative in recognition that the maintenance of inland and coastal water quality has become a critical global challenge. And they highlighted the value of integrating ground and space-based observing systems to improve the management of this vital resource. In parallel, the International Committee on Earth Observation Satellites, or CEOS, commissioned a study that was actually led by CSIRO, which found that existing and currently planned and funded Earth observation satellite missions are not adequately designed for the systematic monitoring and assessment of inland and connected near coastal waters. This is because those current and planned satellites were designed either for ocean, land, or atmospheric applications, and they therefore lack the required combination of spatial, spectral, radiometric, and temporal resolution that would be optimal for small water bodies and narrow rivers. So this remains a recognised gap in global satellite observing systems, where Australia can play a significant and globally relevant role. A national water quality monitoring system would look at both inland and coastal waters. Good coastal water quality is critical, of course, for recreation and tourism and fishing, but also for our marine ecosystem health, for example, protecting our seagrass meadows, and our aquaculture industry. As an example, toxic algal blooms, which occurred off the east coast of Tasmania in 2012, led to a global shellfish product recall that was worth $23 million. Safe and clean inland freshwater supplies are critical for both rural and urban communities, livestock, agriculture, and wildlife. Water quality can be affected by both natural or human-made reductions in river flows and dam levels, warm temperatures, algal blooms, fertiliser runoff, bushfires, and soil erosion. Harmful algal blooms alone have had a massive impact across Australia. Over 1 million fish died in 2019 in the Menindee region alone, and the economic losses from toxic algal blooms in the Murray River in 2016 were estimated to cost around $250 million. Contamination of our water supplies following widespread bushfires is also an issue we see in Australia right now. Major bushfire events have very high potential for large volumes of contaminated ash and nutrient-enriched sediment runoff into our freshwater reservoirs and coastal waters following significant rain events. And you may have actually seen in the news just a few days ago that one of the dams that supplies Sydney's drinking water was heavily contaminated in this way. And we are yet to measure the full impact of this summer's bushfires on key freshwater reservoirs. So it's these types of events that warrant a national scale capability that can monitor and predict on a near real-time basis the impacts of these events on Australia's limited freshwater resources. So one of the research areas CSIRO is exploring with the SmartSat CRC is the development of a national water quality monitoring system which will provide precise, real-time, decision-ready information on our nation's waterways, coasts and reservoirs, as well as their variation over weeks, months and years. A national system like this would integrate data from new, specially designed satellites and ground-based sensors, as well as building on the existing monitoring networks that already exist. And the data then would be integrated via a custom version of the Open Data Cube to deliver information in that decision-ready form to facilitate better water resource management for the benefit of the community and industry. And a mission like this would also have global benefits as well and provide additional opportunities for international collaboration. Thank you.
Okay, now we will proceed to a couple of questions and answers here. And so first I want to just kind of put a general question out to all of you, for all of you to kind of think about this question, and we'll do just one person at a time to try to address it. And then I want to ask you some specific questions about your particular area of contribution. So when we talked about the fact that R&D is a really important part of economic growth, and if you're going to do an effective job at making some decisions, it needs to be strategic. So how are you going about prioritizing what kinds of investments you make in R&D, and how much of a priority, how much of an importance is it in your organizations to support research and development as opposed to just product development and so forth and so on? So we'll start with you, Peter.
Thanks, Christyl. I'll start the answer and then I'll pass to Andy, I think.
That would be great.
To talk about this. It's absolutely critical that we in the SmartSat world, the innovation, research and development world, understand the needs of our partners. We've got over 100.
Right.
And they're primarily drawn from the private sector. 50 of them are startups. There's a large number of publicly funded research organisations, CSIRO, and around 18 universities, Department of Defence through DST. It's absolutely fundamentally important we understand what the big challenges are. We then got to equate that to the impacts that are derived by overcoming those challenges.
Yeah.
And then we've got to marry our ability to bring the right science to bear, to actually deliver the research outputs that can then be adopted to realise those outputs. And to understand that, we really need to understand our ecosystem, so the supply chain and the value chain that goes with it. So that's the context of it. With your permission, Christyl, Andy might fill out the next level of detail.
Thank you very much, Peter. Yes, it is exactly as Peter said. It is very much following the need of the end users and our industry partners, but also looking at the strengths, playing to our strengths, as the Minister mentioned today, so that we will be able to have the capability or have the ability to develop that capability so that we can meet that challenge. So it is very important, and in the SmartSat CRC, we are very focused, together with our industry partners who are driving the research effort. It is very much paramount of what the impact of this research will be. And in order for us to identify that, we need to identify what are the grand challenges that we can provide some input in solving, and where are the end user needs for that. To that end, we actually in the SmartSat CRC have established 5 sectors, 5 end user groups that are made of advisors, of high-level advisors in those sectors, in agriculture, in mining, in telecoms, transport and logistics, and of course defense. And they will guide the program, the research program for us.
Wonderful, wonderful. Okay, so Craig, satellite communications is something that's going to be really important in everything that we do. And so how does EOS Space Systems kind of figure out and focus what you're going to invest in? And do you all have an R&D program that specifically focuses on what you're going to do in the future?
Yeah, so R&D and innovation is actually, I know we come from the industry side, but R&D and innovation is actually at the heart of everything we do. EOS has always been a technology company, and the Space Systems is really the IP generator in that organisation. So we value our collaborations with the universities, but we generate that IP and then we distribute that to the different divisions to turn into products that we can sell. And again, coming from the industry side, it's great to do R&D, but you do have to turn it into something that generates revenue, creates jobs and business going forward. So in getting to a prototype, that's kind of where our R&D finishes, and then we hand it to one of the divisions to generate into products to turn into something we can sell, and we've actually been very successful at doing that and exporting of those systems. So it's a fairly, EOS is unusual. We take a very strategic long-term view of products we're going to do. Companies are often criticised for only worrying about the next year's balance sheet. We actually take, probably to our detriment, have taken long-term views of things, but it's actually really starting to pay off now, and we're seeing that rapid growth in all those products and the IP that we've generated and being able to turn that into a real value.
Great, thank you. So Kimberley, how are you all thinking strategically about making your choices for your R&D programs?
So CSIRO, being our national science agency, we are focusing our work on 6 national challenges that we've identified, and that frames all of the R&D that we pursue. These 6 challenges are key to our quality of life, for the economy and for our environment. Those challenges are related to enhancing the resilience and value of our environments, ensuring food security and quality, enhancing health and well-being for all, helping create future industries, ensuring sustainable energy and resources, and ensuring a secure Australia and region, which secure in the sense that relating to not just war and terrorism, but also things like pandemics, biosecurity, disasters, and cyber attacks. So everything we do is framed within helping to address these national challenges.
Great. And Bruno?
Well, I will immediately address your question, but let me take the opportunity to formally announce with a great pleasure and jointly with my friend Michael Lenton the fact that Leonardo Australia signed the agreement with SmartSat today, and we signed also the agreement with Leonardo Australia in order to cross-support the activities we will carry out for SmartSat. So it is really a great pleasure for us.
Congratulations. Yeah.
Thank you. Thank you so much. And I really want to add that what Andy has just said in terms of in terms of proximity with respect to the end user for capturing the requirements is like playing an Italian opera for me, because we are a downstream company, and all our focus is on end users and the needs of end users. If you like, there are so many images available on many systems all over the world, optical, radar, hyperspectral. But the real point, in my opinion, is joining and linking the points in order to reach the end user, which is many times what a huge space program is going to forget or miss. So in order to respond to your question, the answer is somehow implicit. We are investing a lot in research and development, and also in product development, because we are a very profitable company, and our areas are somehow similar to the things we have listed so far, because we have defense and intelligence for land monitoring and maritime domain awareness, agriculture, emergency response services, and ground motion and critical infrastructure monitoring, as I told you before. On top of this, there is the need, let's say that more and more the pattern is shifting from interest in image products into an interest into information products. So we need to feed this paradigm change with research and development in algos, which are going to extract almost automatically information from images. But it's more than that. It's to give to our customers the possibility to easy access this marketplace, because more and more we are also entering in a sort of subscription economy, also for remote sensing data and information products, which was probably totally unbelievable some 5 or 6 years ago. But in order to be prepared to this paradigm change, we need to invest a lot in research and development.
Absolutely. And so that's a very, very good point that you talked about, going from image products to information products and making that shift. It's going to be very, very important for us as all of the globe puts the first woman on the surface of the moon and then on to Mars. It's going to be very important for us to be able to transfer information very, very quickly, and to be able to transfer products to information that can be actually utilized in multiple venues. And so how are you going about doing that within your organization?
Me again?
Yes.
Okay. Well, you touched a number of very interesting points, because it's not just a matter of providing information products. It's also a matter of providing information products by respecting the timeliness or the service level agreement requested by the end user. So the solution to this demand is reducing as much as possible the latency for the availability of raw data, which are the very first step of this process. For this reason, just to make an example extracted from the Cosmos climate system, we can support the so-called direct access to the constellation. So we have some 13 terminals installed all over the world at the premises of our customers, so that they are totally autonomous to order, acquire, process, archive, and disseminate the data. And this is what we are currently discussing also with Leonardo Australia in terms of step ahead, which we could do in Australia to cut down the latency for the delivery of image data in Australia. But this is only the first step. Then you need to plug a number of application platforms if you want to extract information contents. So essentially, the solution that was designed through the years in our company is the development of an application platform devoted to each of the verticals, which I listed before. And of course, those platforms are not stable at all, in the sense that we are on a daily basis capturing the new requirements of the end users. And this is what we want to do also with Andy in SmartSat. So those platforms are open, are framework in order to plug in new solution and new requirements. And you have to do this really very fast. And then, as I told you, we have a sort of overarching architecture, which is the access for subscription economy, with a platform which is named Kleos, and allows an easy subscription of the user for them to acquire directly the information products, which could be the analysis of the formation of a building, an oil spill report, or a vessel detection report over a given AOI.
Okay. And along this line, Craig, how do you see optical communication transitioning to the mainstream satellite communication market?
Yeah. So I'll preface that by saying EOS has recently diversified the business a little. We've been traditionally a defence and space business. We're now adding a communications arm to that, and we think we can bring some capability there, having been an optical company along the way. Well, we see an almost insatiable demand for bandwidth in space coming along. Some of that is the Earth observation, high-resolution sensors needing lots of information, but there's an explosion in Internet of Things and also remote operation of unpiloted automated vehicles from across the continent, from across the planet, which just need high bandwidth and low latency communications. So we see the optical comms plays a role in that, and we've been developing that, working with our partners. We're involved in the SmartSat CRC as in principle to develop optical comms capabilities. We're working with ANU, EM Solutions, DST Group, who are interested in defence aspects of it, and Scholl Group. And so we're going to, where was I going with that? Oh, yeah, sorry. So optical comms makes perfect sense for cross-links between satellites, but when you're talking about high bandwidth, low intercept links of satellites, and it has low interference as well. So it's a great capability for in space. For the Earth to space and space to Earth, we have to think a little bit about exactly how we utilise that. Yeah. It's because I call it optical comms. It's a sometime service. You just can't have you don't have the reliability and guarantee of being able to use a service that you get with microwave comms. So we have to think about where we go with that.
Okay. And EOS has made some recent acquisitions in the communication sector. Can you tell us a little bit about that?
So we recently, as part of this sort of transitioning to an optic communications company, we acquired EM Solutions, who is a highly respected satellite communications optical on-the-move terminal provider from Brisbane. They're being absorbed into our communications division, and we're working with them closely in the SmartSat to develop the we're calling hybrid optical comms terminal, hybrid microwave optical comms terminals, and that's in the CSC. It's probably a good place for an R&D exercise, because it's a project which, for the first time in my life, I'm going to an R&D project with no idea how we're going to actually solve this problem. And so it's probably high risk but high payoff if we can make this hybrid system work. But EM and we are critical on that. And also, if we're going to bring optical communications into the mainstream, then we need to layer on top of a traditional microwave system, because you've got to have that reliability guarantee of service that you just can't get with optical comms. So what we're doing is starting off with a traditional microwave communication system, and then layering on top of that the optical comms. So initially it will probably be side-by-side systems, but then we'll generate the hybrid system, so you have a single terminal to provide both optical and RF comms to get the best of both worlds. The guaranteed service delivery when you need it, all weather, all time, and then the high bandwidth when it's available.
Right. Okay. So let's kind of bring this back up another level to a higher vantage point for a second, because we're ultimately talking about how are we going to make sure that Australia is positioned to be really efficient and really effective going forward. And Peter, you talked about a roadmap that you were going to be trying to pull together. Can you talk about how we're going to optimize the space and spatial industries here?
Thanks, Christyl. We need to have a critical understanding of what our sovereign capabilities should be here. We know, and this conversation on comms is telling us that in regional, rural and remote Australia, we have significant bandwidth and communication issues. We're just not meeting the needs of many of our users. And as Craig has just explained, there's an exponential increase in the volume of data and therefore the demands of users going forward. So our problem is just going to get worse. So how do we resolve that issue? There's a critical question that the nation needs to come to a point of view on, and that is, where does public investment need to be put in order to make the pie grow larger for everybody? So essentially a market failure. And where does the market operate and can be allowed to grow and flourish? We need to crystallise that. We also need to marry up the high aspiration of our innovative companies, both those that are domestic and international, with their strong innovation and R&D agendas, their ability to fund it. And there's a lot of opportunity out there for making the case for VC funding really along that cycle, all the way through to our superannuation funds that have got very substantial resources in them, to bring to their attention the potential of our rapidly growing space industry. So that would be the sort of the second point that I'd say. And the third one is the civilian defence relationship, absolutely critical to any nation that wants to be in space, and bringing a much greater awareness of the synergies of those two sectors together as part of the roadmap will also help us optimise the roadmap and the outcomes associated with it.
Great. And some of our conversations that we've had offline, we've talked about the fact that there are many who say that you need substantial investments, additional funding from the government in order for you to actually be able to do this right. What are your thoughts on whether or not you have to have substantial increases in funding to do anything in this area?
Yeah, good question. My thought is that there is a lot of existing money on the table or clearly earmarked around space and or next generation science. So let me illustrate that. SmartSat's got 245 million of cash and in kind, and it's just started its journey, and it's dimensioning its detailed strategic investment portfolio at the moment. So grand opportunity there. We know that there's $150 million that the Prime Minister's put on the table for Artemis, which is to stimulate the Australian industry as part of the Artemis program, another $150 million. Defence has got the innovation program, which has got many hundreds of millions of dollars in it, some of which can well be earmarked for space. And Defence has also spoken publicly in this forum, in fact the last forum, about the potential to bring several billion dollars into the pipeline too as part of its forward-looking space needs. In addition to that, Australia has a National Collaborative Research Infrastructure Fund that was recommitted to by the Australian Government, in fact by the Prime Minister when he was Treasurer in 2018, and the budget paper forward estimates put $1.9 billion into that program, and as well as $150 million worth of recurrent funding into it for existing facilities across a broad range of sciences, but also with the distinct possibility of bringing some of that to bear into new areas, and we should make the case for space, and in fact that case is being developed at the moment. So my observation would be that we really need to work that much harder first before we say, hey, there's not a lot of money around, we need some more.
Right, right. And so we're all very excited about the new space agency and the SmartSat CRC as new kind of entities within Australia, but there have been some very long-standing organizations like the CSIRO that have been doing, you know, lots of these kind of activities for quite some time that have been beneficial to not only Australia but to the world. And so looking at CSIRO, Kimberley, what's different from back in the day and now? What are the differences? How are you having to transition what your organization is doing?
Yeah, you're right. So CSIRO actually has over 70 years of history in space science activities. A lot of that was focused on operating national facilities like our Australia Telescope National Facility and the Canberra Deep Space Communication Complex outside of Canberra, and also developing Earth observation data analytics and applications. But over the last 5 years or so, just looking broadly at the space sector in Australia, I can think of two key developments that we've seen that have really started to change things. We've seen a very rapid growth in the number of innovative space startups in this country, which of course is reflected in the very industry-focused mission of the Australian Space Agency. From a CSIRO perspective, over the last several years, we've also been broadening our space focus to identify and target more of those opportunities to grow the Australian space industry. So many of you may be familiar with our Space 2.0 workshops, where we've been looking to partner with startups and foster their development. We also started my program, the Space Technology Future Science Platform, just over a year ago. The specific mission of that program is to develop new and innovative technologies that will lead to the development of the industry in support of the Space Agency's industry growth goals. And the other main development that I would note is that we've seen access to space becoming more widespread. And for CSIRO, that's included partnering with international organisations on the NOVASAR-1 mission, which we have a 10% capability share of, capacity share of. And we're also developing our own CubeSat. That would be our first CSIRO-owned and operated satellite. And in the future, like I mentioned earlier, possibly water monitoring satellites. In terms of what these changes within CSIRO actually mean for Australia, these changes will provide more opportunities for Australian researchers to access Earth observation data from missions that are specifically designed for Australian conditions and operated for Australian needs. We can download the data here into Australia and have that near real-time access. And it also provides more opportunities for Australian industry to leverage CSIRO's space-related research and development activities into commercial opportunities.
Okay, thank you. And so what do you, from your vantage point, what do you see as the key issue that Australia needs to address in order to build a vibrant space sector?
So,
Kimberley, since she was talking about that.
So I think that this is really part of what Peter mentioned a bit earlier on, is that having that end-to-end Australian supply chain and value chain that has the reach into international markets. I mean, it starts with the R&D where we're at largely. It spans all the way from Australian space-qualified hardware down to commercial, government and other end users who are actually utilising the space-derived data to support their decision-making and their direction setting for our country. And also serving national and international markets. So, for example, by supplying our international partners through NASA's Moon to Mars mission. But one of the challenges I think we're looking at in the development of that is really demonstrating the space qualification, the reliability of Australian space industry innovations, because we're coming into a lot of this sector fairly new. And that's going to be a key challenge to gaining access to those international markets. And so perhaps a national mission like this water quality monitoring mission might be one way of addressing that.
Okay, great. Okay, so Andy, you talked about the possibility of tripling Australia's space economy by 2030. And that is certainly that's no easy feat. What are the key capabilities that Australia needs to build in order to optimize the path to achieving those objectives?
Well, we have discussed some of those now during the panel, and we have discussed the roadmap that we are developing, the industry growth roadmap. And of course, our space agency is doing a great job, has already done a great job in identifying the areas of focus for Australia. What we would want to do is to align with those foci. I think it's important for us to really focus our effort in fewer areas and do them well, so that we can actually excel. But also, in my view, we also need to focus on collaboration. I think that's so important. Peter spoke, the question before was about money. If I have 20 cents, I can buy one lolly. If you have 20 cents, you buy one lolly. But actually, if the 6 of us put our 20 cents together, we can get a whole bag of lollies, and that's more than 6. I think we need to have that mentality in Australia where we really build the collaboration. The SmartSat CRC is not going to do research that the CSIRO is already doing and is advancing because they have that very strong heritage and strong capability. We want to bring everyone together so that we have some fantastic research capability here in Australia. We have GA doing magnificent work with the Digital Earth Australia and the information products we discussed. We have many of our partners, industry partners, that have telecommunications expertise like E-Geos and others, and of course our universities. The trick is for us is to identify where we are going, and the space agency, I think, is doing a stellar job in helping us do that, and then to ensure that we all play together so that we don't have parallel efforts. We cannot afford parallel efforts. We all push in the same direction to achieve it.
Yeah, and that is absolutely important, but the key is how. How are you going to do that? How are you going to increase collaboration between industry and academia and others?
That's a very good question you're asking me to reply.
Absolutely.
I can only speak for the SmartSat CRC, but the doors of the SmartSat CRC are wide open for collaboration. What will we do within the SmartSat CRC? 3 things. First of all, we will mandate collaboration. None of our projects will have any chance of success if they come from a researcher by themselves, or a university or a research organization by themselves. We already have a policy of ensuring that there is collaboration, not only to researcher collaboration, but even more importantly, the researcher to industry. So we've already mandated that. The next thing that we will do, and we have the advantage, because we do have 100 willing partners that have come to the table and said they want to play. And as from today, we have more. So I think what we will do is we will make it easy for industry to identify the capability, to make that collaboration, that matching that is required to have a proper project, collaborative project. We will make that easy for our partners, both researchers and, of course, our industry partners. And finally, what we will do is we will allocate a lot of resource and effort to ensuring that as the project progresses, we're not going to just fund and forget, like some agencies might do. Some research funding buckets are very much that. You just get the funding and then you say the university does some work and eventually they come up with something brilliant, but often maybe not. We will manage the process of the projects as though it is an industry project, because it is. We will manage with support, project management support, technical support, and more importantly, through our industry partners, make sure that we translate together, we work together to translate that IP that we generate, and we develop commercial value. Rather than the universities identifying an IP that is unique and then saying, oh, how are we going to commercialize this? Let's have a startup. Startups are very difficult to succeed, as you know. Often what happens is that innovation goes overseas because that's where the money is. We need to bring it here, and by partnerships with our industry partners, we will be able to actually go through the entire TRL level for us to commercialize that IP. You know, researchers love two things. They love money. Researchers love money. But the other thing that they do love, they love to see their research being applied. And therefore, through an industry collaboration, that actually happens. And unfortunately, up to now, Australia has not really been that good between industry and university collaboration. We want to change that.
Good, very, very good. Okay, so if the goal here is to really build a vibrant space community here, and it's to really triple the space economy here in Australia, it's important for us to have a plan. It's important for us to have the roadmap that you talked about. It's important for each of us to be thinking about the way forward in a positive way. But at the same time, it's very, very important for us to think about the challenges and the barriers to your success. If we're not thinking about the barriers up front and making sure that we have answers and solutions to some of those barriers, then it's going to take us a long time to take a trip that could have taken much shorter in time. And so, Andy, since you were talking, each of you, I'll go down the line, each of you just tell me what you consider to be one of the largest barriers or challenges to the growth of the Australian space economy.
Well, I've already kind of mentioned the first one in my previous answer, which is lack of collaboration. I think that if we have parallel efforts and each of us go our own way, then it's not likely for us to achieve the end goal. But I'll offer another one, and that is lack of focus and relevance. It's very important for us, once we began this journey, to focus on the task at hand and not then wait for the next shiny thing to come along and change direction. So focus is very, very important for us. R&D is not a very simple thing, and it's not a very quick thing. You need to actually have the stamina to take it all the way.
Absolutely. Do you have one, Bruno?
Well, I do apologize. It is a little bit more difficult for me to identify barriers in the spreading of the Australian space industry. But I can bring my let's say, expertise in Italy, in Europe, or outside of Europe. I think our point of strength of our company is really thinking out of the box, because the Earth observation market is changing so fast that a partnership is at the core of our values. And you have to partner with companies which you couldn't believe you could partner some 10 years ago. I will give you one example. A couple of weeks ago, we had the so-called roadshow of Telespazio and E-Geos to set up the objectives for 2020, and we invited Accenture. The representative from Accenture gave a lecture during this meeting, and since he knows E-Geos quite well, he told us that in the almost 25 vertical markets that Accenture is following, in all of them, there is a space for Earth observation solutions. So in my opinion, this is really the message that I want to carry on during this meeting, because the Earth observation solution and again information products can really be applied everywhere. Just I made before the example of moving from emergency response service for institutions to emergency response services for insurers. But the very same technique we developed for defense and intelligence can be applied for business intelligence, because the boundary line between these two worlds is extremely fuzzy. And you can move from defense and intelligence into business intelligence exactly with the same platforms, exactly with the same solution. And the market is really asking for the delivery of timely information. To make an example, we are monitoring all over the world the crude oil tanks, thanks to the floating floor of the tank. And of course, we are integrating optical and radar, because that's the only way to provide on a weekly basis the reports which are asked for by our financial customers. So again, it is another example. Earth observation is leaving environmental monitoring and entering the huge name of financial markets, like Bloomberg, like Goldman Sachs, like JP Morgan. So in my opinion, partnership with the huge companies, but also partnership with PMI or startup, thinking out of the box are really the ingredients which could generate the success and the expansion of the Australian space industry.
Absolutely. I think that's a really important point. So when I started my opening remarks, I talked to you all about making sure you have the out-of-the-box thinking. One of the biggest dangers to moving forward and innovating is groupthink. So if you have people who are accustomed to working together and people who have the same backgrounds and the same experiences and the same everything, you get that groupthink. And so if you don't have people pushing back on you saying, why are you doing it this way? And can't we do it another way? You're not pushing the envelope enough. You're not actually being as innovative as you think that you are. And so it's really important for you to find those trusted team members that you can bring in that maybe aren't even in your field and say, this is my problem. Let's think about some solutions together, and you'd be amazed at the kind of innovative solutions you get when you're really thinking outside the box. So thank you for that. That's a good one. Okay, Kimberley, do you have a thought?
I mentioned some challenges before, but now I might just pick up on a couple of points that Andy mentioned, particularly the translation of our R&D into commercial outcomes.
Right.
I think has been a bit of a challenge for us. And the other is the focus that he mentioned, being really strategic about where we choose to put our resources and identifying those leapfrog opportunities where we can really jump ahead to provide something that is globally competitive and unique.
Great. And so it's going to be very important. That's really an important point, too, to be able to transition things from the research and development into commercial. At NASA, we've had to have a program that's specifically focused on doing just that. And we have a team of people that do nothing but really thinking about it. developing the processes that we use for it, making sure that we're communicating with the industry. This is what it's going to take for you to take our technologies and develop them further so that you can commercialize them. And so that needs to have some real focus if you want to make sure that it doesn't become a barrier. So that's very good. Thank you. Craig.
So going back to the challenges we're experiencing, and our biggest challenge at the moment is just finding enough suitably qualified, experienced staff to take on the projects we have. We're adding projects at a rate which we actually almost setting ourselves up to fail because we just cannot get enough qualified people. So for us, the whole STEM agenda is actually significant. We're teaming with a number of universities, a number of ARC programs to try and develop new talent. We're having to take a long-term view. If we're going to put people through degrees and PhDs, we're talking about 3 to 6 year view before you even get someone you can start using. It's where we got a lot of value out of the CRC for space and environment management. A good number of the PhDs and students that came through that program we have recruited. Some of them are in this audience today. And I think that's one of the things we see out of the SmartSat CRC as well, is that pool of talent coming through, being trained up, getting exposed to a wider variety of experiences in the industry, and then being able to basically recruit people.
Very good. And Peter?
Clarity on sovereign capabilities, quantum key communications, artificial intelligence, perhaps at every part of the supply chain, from onboard satellites all the way through to in the terrestrial data stores. The terrestrial data stores themselves, where they're located, what their architectures are, how they're protected, what analytics and systems we put around them. What sovereign capabilities and sovereign systems do we wish to have in Australia? Markets love certainty, and if we can move in that direction, that will help grow the market more quickly.
Okay, great. All right, so if we have anyone in the audience that has any questions, could you please come up to one of the mics? And I'm going to, while we're doing that, I'm going to address one of the questions that we have from someone online. This person is Ivan. In 2006, Sir Ken Robinson said, "If you aren't prepared to be wrong, you will never be innovative. Can the Australian Space Agency be tolerant to failure, or will risk aversion stifle us?" That's a very, very good point. And one of the things that I've been having conversations with Megan about is, and you heard multiple times that this is hard. Going to space is hard. Everybody knows that. But what does that translate to when it comes to the day-to-day operations? There will be failures. You will have tests that will go wrong. You will have real bad days in this industry. That's just the nature of the game. If you get to a point where you don't internalize that and you allow one bad day to now say, we cannot do this anymore, the public won't tolerate us having these kind of failures, we're not going to be able to invest in that anymore, you might as well stop right now, because that is just going to happen in this business. And so it's really a matter of understanding what your risk posture is and making sure that you're prepared on a day-to-day basis to mitigate those risks the best that you absolutely can. And then when you have an accident, because you're going to have them, even after you do all the mitigation that you can possibly do, you'll find that those really bad days, like we had for the Columbia accident, our whole engineering community came together and said, we will never make the same mistake again. I'm an engineer, and I wasn't one of the people who was actually looking at the specific problem that we had, but I felt it deep in my core. We all had to walk past a wall that had a banner on it from the kids of those astronauts who were on the Columbia, and the notes that they were sending to their parents, excited for them and can't wait to see you when you get back. All of the engineers, we had to walk past that and look at that and internalize that. So it was every single one of our fault for having an accident. That's just the way that it goes. And so it's real. It's real. And so it galvanizes your whole country when you have those kind of, it galvanizes the whole community. Because the country may not understand. Some of the taxpayers will just be like, oh no, you had a teacher on board, or you had this person on board. But the community has to be able to stand together. And the community has to come together with everybody, every smart thinker that you can bring to the table so that you can figure out what happened and make sure that that same mistake doesn't happen again. So that's really important for everyone to remember. Right. Yes, sir.
Mark Stewart, University of Adelaide. We've had a lot of focus on improving existing space industries in your talk. Better optical communications, better use of the remote sensing data and the like. But we haven't heard very much about new space industries and whether SmartSat CRC has any engagement in that, say, monitoring of asteroids for mining purposes or development of fuels up in space. Do you see the SmartSat CRC as having any engagement in that? And if so, could you elaborate?
Our current agenda is that we would be applying our technologies for looking down on Earth. But that does not mean that some of our technologies could not be used for the Artemis program and any other programs that are, in fact, interplanetary exploratory. But one thing that has been said, and we didn't highlight very much, which is new for us and for many research organizations in the world, is why we call this SmartSat CRC smart. Because we talked about making bigger pipes because Earth observation sensors will require that for us to download all the data. But one of our very big pillars of research will be to apply AI, new techniques in AI, so that we can actually do a lot of the processing on the edge. So rather than actually having in the new space, in the new platforms, having a platform that is reasonably intelligent in terms of the comms and understanding its own health and so on, but most of the payload is really dumb because all it does, it does a great job. It captures the data and sends it down. We want to change that. We want to put the machine learning models and the AI techniques so that we have an onboard processing on the payload itself, so that when you are gathering that data, as it was mentioned before by E-Geos and others, you analyze the data on board, and then you send down the information product or even the actionable kind of instructions. So that's one area we will be focusing very heavily in the SmartSat CRC.
Thank you.
Okay, and another question for you, Peter. What organizations are being approached to create or drive the creation of that white paper you talked about, the ecosystem map, and the risk analysis?
Thanks, Christyl. That's a good question. There's a long list. I think it's probably 12 to 15 have been approached at the moment, and they include, and principally, the two industry peak bodies, the Space Industry Association of Australia and the Spatial Industries Business Association of Australia, that have very substantial memberships that reach out into the private sector. At the government level, we've had conversations with Geoscience Australia and with a range of state agencies, both individually and collectively represented by a body called the Australian-New Zealand Land Information Council, which is the peak body of all of the governments of Australia and in fact New Zealand as well at all jurisdictional levels. We've been able to reach out to quite a number of the key partners within SmartSat itself directly, and some of the professional bodies, including the Surveying and Spatial Sciences Institute. We had discussions with CSIRO, Geoscience Australia, Defence, and so on. I could go through a long list, but
with your permission, if I may add, the Space Agency.
Well, I was going to finish with that. Yeah. All of this is being done under the auspices of the Space Agency, and it would be entirely aligned with their needs and strategic aspirations, and we would be looking to them to make sure that they guide and steward all of this. So thanks, Andy, for reminding me on that.
Okay, this next question is for Kim. The Australian Earth observation data sets and capabilities would be significantly enhanced by hyperspectral remote sensing technology. Are we planning R&D for this?
Thank you. So that's actually one of the... Okay, thank you. That's actually one of the areas that we are pursuing right now under my Future Science platform. We have a project that is looking at, or has looked at, taking hyperspectral data and creating a hyperspectral data cube, which is a bit mind-bending because it's kind of a cube of cubes. But now we're also looking at taking that a step further and being able to integrate that with other types of data as well. So yes, we are definitely looking at that, and we certainly see the value of that.
Okay. Oh, yes, sir.
Hello, I'm Tommaso Randolfi from LeeSpace. So when talking about all this new space economy in order to support these new missions, a crucial aspect is telecommunications. And all these new networks that, in order to support these new requirements that Dr. Versini was mentioning before, like latency, real-time communication, and amount of data, will need to be spread all over the world. And this will mean interacting with countries which have very different legislations in terms of telecommunications. And LeeSpace is actually working on this, deploying systems all around the world. And we are facing this problem. Australia, for example, is a country where this legislation is kind of hard, especially considering all the requirements and the aspects concerning telecommunications from the satellite point of view. There are other countries like also USA that is pretty hard for licensing, and other countries which have no legislation at all. So how your companies, agencies, are planning to deal with this problem and interact with this country?
I can pick up the question. Yes, good point. Let me analyze the question from different perspectives. First of all, many Earth observation satellites are in an SSO orbit. So it's the best solution is to have an high latitude ground station. And as far as I know, I never encountered problems for downlinking data in high latitude station besides the Svalbard Islands, because there is an agreement protecting Svalbard Island for it's preventing the use of military satellites. But you can download data in Kiruna or Tromsø. One more solution is the use of interorbit link, which was addressed by Craig. And again, I want to see interorbit links with the user perspectives, beside the fact that you can optimize the downlink of the data, which is pretty straightforward. I think what interorbit link is granting, it's the rapid commanding, so that if there is a, let me pick up an example from real life. When you are making maritime surveillance, usually you do the detection with radar data and the identification with optical. The problem is the orbits and the fact that you have to rapidly retask an optical satellite. If you want to take an image for the identification of the ship before the shipping is moving away. So that's where rapid telecommanding is really helping. And to make an example, in the European world, the European Space Agency has embarked interorbit link on Sentinel-1A, 1B, 2A, 2B. So we are in the position to task those satellites and also to downlink quite rapidly the data. One more point is that, again, to provide an example, we have a space center in Matera, side by side to the one controlled by the Italian Space Agency, and we can provide near real-time services essentially over the Mediterranean. But since, thanks to an investment from ASI, we installed an EDRS terminal. EDRS is the European Data Relay Satellite System, like the USA TDRS. We are in the position to expand the footprint of the Matera ground station to provide the near real-time services. Just to give an example, till the eastern coast of Brazil, which is unbelievable, I am at home and I can provide near real-time, maritime domain awareness, near real-time services on a huge space of the sea. So, skipping back to your question, since we have, as I told you, 13 receiving terminal all over the world, I never had a problem in legislation for downlinking data, but of course I had the advantage of being at home of the customer that wanted the Cosmos Climate data. I know for sure that there are a number of high-latitude service providers which are providing access to American satellites, I guess also Australian satellite, definitely to Italian satellites. If and where there is a problem, of course, it must be addressed. But as far as my experience is concerned, we didn't really had problems like that in downloading data or uplinking telecommands to the constellation.
Okay, and this next question is for SmartSat CRC. So would it be a consideration of the SmartSat CRC to encourage or direct educational efforts outside of PhDs that would bolster the Australian space industry?
And the question is, should we do it? Is that what I'm...
They're saying, would it be a consideration? Would you consider doing
absolutely,
that?
Absolutely. Indeed, we are doing that. We have established a college of experts, an advisory, high-level advisory board that we call the Education College. And that has representatives from across the whole value chain, across the educational system, from the education department, the TAFE system, universities, of course, industry, training and providers, and so on. And the first thing that they will be doing is working through a training or a skills gap analysis to identify what those skills, the required skills are, particularly for new space. And once that has happened, we will be moving towards looking with the educational providers to design programs that they would be running, but with our support, so that we can indeed produce not just PhDs, but also engineers, scientists, IT, software developers, or machine learning experts, and so on. We have promised the federal government that we will graduate 73 PhDs, and also under our support, graduate more than 400 of those engineers, scientists, etc. So absolutely, yes.
Okay. All right, and so I would not be fair to the people online if I didn't ask at least one question, because so many of them are talking about sustainability. So they are saying, you know, what about space sustainability? Near-Earth space is a limited resource. Please discuss thoughts about space traffic management in the context of growing mega constellations in low Earth orbit. So any thoughts on that, or if you don't have thoughts on that, are there any plans as you're kind of thinking through priorities maybe for SmartSat CRC that are looking at that sustainability? And CSIRO, if you're considering any of those things. Anyone? Oh, Craig's got something.
Well, I'd say space sustainability is kind of our business. We've been in the satellite tracking, collision avoidance business since the company was started 35 years ago. So that's what we do, space traffic management. We're working on space surveillance, making sure we know what's there, what it's doing, where it's going, and then space traffic management, coordinating, making sure things don't crash, safety of flight. So it's very much in our minds. Leo, it's going to be a worry when we get 12,000 or another 10,000 satellites up there. They're all, people build little satellites. Usually that means they don't last very long. Once they stop operating, they become space junk. Only a small proportion of deorbit maneuvers actually work. So a lot of that stuff, even though there's a plan to deorbit stuff, it doesn't always work. And so we've got an issue there. There are lots of ideas about going up and sending systems up that harpoon satellites and bring them back down into the atmosphere to burn up, but they're all horrendously expensive programs which no one really wants to fund. To me, there is a near-Earth or an Earth orbit pollution issue. We've done what we did to the rivers and the oceans. We've dumped all our crap there and just left it there. We got economic benefit from putting it up, but we don't get economic benefit from pulling it down until you actually have a crisis, just like we start seeing with what we've done in the climate. We put CO2 in the air. Everyone got benefit from putting it up there, but no one really gets benefit from pulling it down until you have a crisis. So it's something we're all going to have to deal with, and very soon.
Yeah.
All right.
If I can make a comment also, I think the results of our technologies that we are building are very much about sustainability and environmental sustainability, particularly the results of our better environmental monitoring, better agriculture, more optimized agriculture will lead to better management and less pesticide and so on that will actually that do have adverse effect on our climate. But even our communications, I mean, most of us, Australia is one of the most urbanized countries in the world because we all want to live in the city because we have better infrastructure, better capabilities there. But in fact, telecommunications, ubiquitous telecommunications in regional and remote communities will encourage more Australians to live. And they love living in the country. It's just that they cannot find work, they cannot conduct business in the country because they don't have the communication systems. So the second order benefits, I think, from the SmartSat CRC technologies and all of the other activity that is happening in space can help sustainability in a big way.
Okay. Kimberley.
Well, absolutely. Earth observation is strictly related to sustainability. Of course, the chapter of sustainability in space is a little bit more complex, even because to respond at best to the user needs, we need a high spatial resolution, but also high temporal resolution. And high temporal resolution means a lot of satellites flying.
Yes.
So it is a difficult subject. But let me go back to the Earth and to the sustainability. I want to give you an example. We use in Italian this terminology, isole di calore, literally translated island of heat. Those are the problems affecting the large cities when, especially in summertime, you don't have the capability to easily remove the heat from narrow roads, just to make an example. We have cross-correlated those information. We made a study on the Milan city, and we cross-correlated these results to the mortality during summertime of old people. And those risk maps are driving the intervention of the city of Milan in order to put in place solutions which are going to mitigate the problem, like removing surfaces which are really black, put green, put trees. Though this is one additional example on how the analysis made on remote sensing data can really improve our daily life.
Okay. All right. Kimberley, we only have 3 minutes left.
I'll just touch briefly again on the space environment management issue. In the CSIRO has been managing radio astronomy facilities for decades, which obviously look out into deep space. But just in more recent times, we have demonstrated that we can actually track near-Earth objects using those same facilities. And we have a project underway under the Future Science platform at the moment, looking to see whether there are other opportunities that we can use our radio astronomy technologies for space object tracking and to assist with the debris issue and other tracking issues.
Awesome. All right, well, I would like to thank all of you very much for the time and being up here on this panel. Please give them a hand. Thank you.
And thank you.
All right.
Thank you, Christyl. If you can stay with me just a couple minutes, because there are some things that we are very proud to do, and is an award for one of our friends, is a friend of all of us, that has been, is, and will be one of the key protagonists of this develop of economy, the space economy in Australia. So may I invite also as a witness Dr. Andy Thomas, if he can come with us, with me, and of course the chair of the Space Industry Association of Australia, so David Ball, and of course Michael Davis, if he's here. Thanks. Please, Michael. I leave now the floor to David to say something about him.
Thank you, Nicola, and it's a great pleasure to be here as the new chair of the Space Industry Association of Australia to be able to present this award. It's a lifetime recognition award to Michael Davis. The inscription reads, "For long-standing and valued service to the Space Industry Association of Australia and the broader Australian space industry, particularly in relation to his 20 years as a board member of the SIAA, highlighted by 5 years as chair, his stewardship of the SIAA as a transition from an association to an incorporated company, his chairmanship of the local organising committee for the 2017 International Astronomical Congress, and his significant contributions in many roles across the Australian space industry. Michael has done a tremendous amount for the industry, one of the quiet achievers. He worked in space in Australia before it became cool and popular as it is today. In the formative years of the ISU summer program here in Australia, Michael did those hard yards and he did a tremendous amount for the Industry Association. So it's a great pleasure for me to be able to present this award to Michael.
Thank you, David. Thank you, David, thank you so much. It is a great honour and a privilege to be recognised in this way. It is the culmination of about 25 years of involvement in the Australian space sector. And I think, if I may be allowed to claim one achievement, and it's a collective achievement, it's not just a personal achievement, and that was that we were able to unite the Australian space community in the decision to bid for and conduct the International Astronautical Congress in Adelaide 2.5 years ago. And that was a 7-year project that united the Australian space community. Everyone thought it was a good idea, everyone supported it, and we achieved great success. We're now embarked upon an even bigger and more important project in our industry, and that is to make a success of the goal of growing this industry, creating jobs and opportunities for our young citizens. And so I think I'd like to repeat something that Christyl said to us during the last session, and that is the community must stand together. And I fully endorse that idea. I believe that success for our industry will involve standing together and recognising that we now have a national agency that is responsible for setting the agenda and giving us leadership. And so if we can stand together behind the agency, we will see the success that many people believe that we deserve. So that's all I want to say, other than to thank all of my colleagues from the SIAA, especially you, David. You were the main supporter of our project, the IAC project, when I was the chair, and I really appreciated your support and friendship. So thank you.
Oh. So I think that we have now 45 minutes or probably more. Now we see again 1:30 after the lunch.